Hello, honors algebra students and algebra students. Mr. Lawrence here, and I've decided this weekend to make some videos for you to help you review some of the concepts for this upcoming final. It's Thursday morning. Oh my gosh, I'm getting so nervous. First of all, this is from chapter 10, but if you were one of my students, and there's some friends listening from another school, that's why I'm saying that. We did some of this earlier in the year, and so now we're just going to review it. So, when I have to simplify a rad, these are all square roots, right? Positive square roots. I need to remember my perfect squares. And so I'm going to make a list over here. 1, 4, 9. If you can't, if you don't know your perfect squares, well, you could figure it out by using a calculator, right? And on the final, you could make this list, or you could put it on your cheat sheet, what your 5 and 8, 3.5 by 5 index card, I'm trying to say. You could write them on there if you needed to, or you could just do 1 squared, 2 squared, 3 squared. For example, 4 squared is 16, 5 squared is 25. Now, I know my perfect square is pretty high, and so I'm just going to make this list now. 49, 64. Where are we at here on 9? So 81. 10 squared is 100. 11 squared is 121. 144. Ooh, that's gross. 169. 196. And 215. No, 225. Excuse me. And I'll go higher than that if I need to, but I think that's going to work for this video. Anyway, so if I want to simplify rad 20, like we all know how to take the square root of 9. We know it equals 3 because 3 times 3 equals 9. When I simplify rad 20, I'm looking for a factor of 20 that's a perfect square. Now, the trick is I want to get the largest factor, largest perfect square factor. I'm not saying that very well. I don't want to just get any perfect square factor. Some numbers might have multiple factors that are perfect squares. I want to use the largest one because it makes my life easier. So since my number is 20 right now, the square root of 20, the rad of 20, I'm going to come over here and I'm not going to worry about 25 or 36 because those are all too big. And I'm going to come here and I'm going to check, does 16 go into 20 evenly? Nah. Does 9 go into 20 evenly? Nope. 4 go into 20 evenly? Sure does. So I'm going to think about this, instead of rad 20, I'm going to think about it as rad 4 times rad 5, with 4 being the perfect square factor. Well, now I can break this up into the product of rad 4 times rad 5. And all of you are so smart, you know that rad 4 equals 2, and rad 5 is an irrational number, it can't be simplified, so my answer is going to be 2 rad 5. Okay, so now I've got rad 50, right? I've got rad 50. So I'm going to come all the way up to 49. Not going to consider 64, it's too big. I'm going to say, does 49 go into 50 evenly? No, it does not. 36, 25 does. Oh, blank, 25 times what is 50? Well, 2, right? So I'm going to rewrite 50 as 25 times 2. I always like to write my perfect square factor first, and this allows me to break it down like this, 25 times rad 2, and rad 25 is 5, so I have 5 rad 2. Okay, I want you to try numbers 3 and 4 on your own. Yeah, you can see 5 and 6 there, but I'm going to explain those in a minute. Pause the video, try 3 and 4 on your own, and then I'll show you how I did them, okay? All right, so I'm getting ready to restart, so if you haven't tried 3 and 4 on your own, please do so. Okay, so I've got 99. Well, 100's too big, so I'm going to go to 81. Does 81 go into 99 evenly? Nope, it does not. 64, no. 49, 36, nope. 25, 16, no. 9 does. So I'm going to rewrite 99, square root of 99, as the square root of 9 times the square root of 11. And then I'm going to think about it as rad 9 times rad 11, and rad 9 is 3 times rad 11, and so my answer is 3 rad 11. Okay, 128, well, let's see here. That's not going in. 181. Oh, 64 is going to go in. So I'm going to think about rad 128 as the rad of 64 times 2, which is going to be rad 64 times rad 2. And rad of 64 is 8, rad 2, and there we go. Okay? All right. Now, when there's a variable involved, this gets even easier. Here, let me get a fresh page up here. When there's a variable involved, see, variables can be perfect squares too. For example, what's x times x? Well, hopefully you know it's x squared, right? 3 times 3 isn't 3, it's 3 squared. So I could do x times itself and get x squared. What would the next perfect square be for a variable where the base is x? Well, it would be x squared times x squared, which would be x to the 4th. And so then if I went x cubed times x cubed, I would get x to the 6th. In other words, these numbers here are all perfect squares. I mean, I just proved they were perfect squares because I multiplied the number by itself, or the variable by itself. You know, if I do y to the 11th times y to the 11th, well, that's going to be y to the 22nd. That means y to the 22nd is a perfect square because I multiplied the same number by itself to get y to the 22nd. So what do you do when you have an odd number? Like, you know, if you ask me to do this, x to the 8th, well, I'm going to think about that as the rad of x to the 4th times rad of x to the 4th. And I could continue to break that down, but simply put, that answer is just going to be x to the 4th, right? If you want, I can rewrite it like this, x to the 4th squared, and then the square and the root undo each other, right? They're inverse operations, leaving me with just x to the 4th. So with the even one, it's easy. You know, you give me y to the 20th. Well, and I know my stuff. I mean, you know your stuff too. So you could just say, well, what number times itself is y to the 20th? Well, y to the 10th, right? But when you have an odd number, you're going to break it down much like we did the opening problems. So if I have x to the, say, 13th, I'm going to think about that as x to the 12th times x to the 1st, which is the same as rad x to the 12th times rad x. And this first part here, wouldn't this be x to the 6th? And then rad x. So that's how it's going to break down. Here, let's try one more. Let's say you had rad of x to the 41st. Okay, well, I'm going to think about that as rad x to the 40th times x to the 1st. Do you notice it's always x to the 1st, right? Yeah, it's always x to the 1st. And now I can say this is rad x to the 40th times rad x to the 1st. And the rad of x to the 40th, what number times itself is x to the 40th? Well, that'd be x to the 20th, and then rad x. Okay, so hopefully that jogs your memory on how to do that. And so I would like you to pause the video and give numbers 5, 6, 7, and 8 a try. I didn't explain ones like 7 and 8, but I think you're smart enough that you can figure it out. So go ahead, give them a try, and then pause the video, give them a try, and then watch my solutions. Okay, here come my solutions. I'm going to think about number 5 as rad of x squared times x, which is the rad of x squared times rad x. And then that will be x rad x, right? Okay. Now you'd have to be careful there because if x were a negative number, then you'd be taking the rad of a negative. So in that case, it's kind of unusual. We're actually going to put that in absolute values. Okay, just be careful with that. Stop and ask yourself, if x were a negative number, would it result in an imaginary answer? Okay. And so here I'm going to get rad of x to the 10th times x to the first, and that's going to be the same as rad x to the 10th, rad x to the first, and that's going to be x to the 5th and rad x, and again I'm going to sneak that into an absolute value right there. Okay, because I've got to have it stay positive underneath the rads. Okay, all right. So how about one like this? Well, you could think about it as two problems. You could do the rad of 54, and the largest perfect square factor of rad 54 is going to be 9. It'll be 9 times 6, and so that's rad 9 times rad 6, or 3 rad 6. And then I could do the x to the 7th. Do the x to the 7th, which I'm going to think about as rad x to the 6th times x, which is going to be x cubed rad x. And so now I can put it together, and I'm going to go 3x cubed rad 6x. Do you see how I put that together? The x cubed and the 3 were outside, so I've got them outside the rad. The 6 and the x were in the rad, so the 6 and the x are in the rad. Okay, here we've got 116 x to the 9th. So I'm going to do rad 160 and then rad x to the 9th. Okay, so now 160, let me go back to my perfect square list. Let's see what's going into 160 evenly. Definitely not 144, 121, not 100. 81 is 162, that's not going to work. 64 times 3, no, that's not going to work. What am I doing, 160? I don't think 49, 36, 72. Wow, I'm not finding any. Is it just 4? That seems too small. Well, I'm going to go ahead and pull a 4 out and see if I missed a perfect square. It's possible. So I'm going to go rad 4 times, and then 4 times 40 would be 60. Now, I'm wondering, is there a perfect square factor in here in the 40? There may not be, but I'm wondering if there is. I sure feel like I missed one somewhere. So I'm going to come down here, and I'm going to do 40. I'm going to break it down into its prime factorization. 5, that's prime, times 8. Look at that. There's a 4. There's another perfect square factor. Oh, how silly of me. 16 would have been the number I wanted. But let's pretend like I didn't know that, okay? And I'm going to keep going. So this is going to be rad 4 times rad 40. But now 4 goes into that again. So now I'm going to have rad 4, right, this rad 4, times another rad 4 from the 40, and that will be times rad 10. Well, this is 2, so that's 2 times 2 times rad 10, or better yet, I could just say 4 rad 10. Now, of course, you realize by now I could have gotten there directly, right? So I've got rad 160, and I say, hey, 16 is a perfect square that goes into that. So I'm going to rewrite it as rad 16 times 10, which would be rad of 16 times rad 10, and then that'll be 4 rad 10, right? And that's what I got. Okay, I got there the long way, just showing you that it can be done. Hold on, I got a sneeze coming on, so you might want to lower your volume. Sorry about that. Okay, so now I'm going to do the variable part of it, and I'm going to think about this as x to the 8th times x to the 1st. And so it'd be rad x to the 8th times rad x. X to the 8th is going to be x to the 4th. I'm not going to need an absolute value on this one. because that fourth will take care of any negative situation. You know what? I think I needed an absolute value over here. Oh, I'm sorry. Don't yell at me. Gonna slide it in on there. Gonna slide it in. Okay. So now the variable part is broken down. So here's the numeric part. There's the variable part. What's outside the rad? Well, I got a 4 outside the rad, and I also have an x to the 4th power. Then inside the rad, I have a 10, and I have an x. Okay, so there's some refresher problems for you. I'm going to end this video. I'm going to make some more, but this is just the first of a few videos. So this one's all about rads, and the next one will be about doing operations with rads. All right, Mr. Lawrence signing off. Have a good night, everybody.